Okay, page 3. First one here is Unit 5, specifically Lesson 6. Sorry, make that so you can see it. So we're finding the solutions to a system of inequalities. To do that, you need a slope-intercept form. The first one is already there. This is going to be a dotted line. So I'm going to go down to 1, and I'm going to go up 5 over 2. And I'm going to do a dotted line. And then I'm going to lightly shade less than or below that line. Second equation is not in slope-intercept form, so I'm going to get it there. Subtract 6x. I get 3y is greater than or equal to negative 6x plus 9 divided by 3. I get y equals negative 2, or not equals, sorry, is greater than or equal to negative 2x plus 3. So I'm going to go up to 3, I'm going to go down 2, right 1. This one is a solid line. So I'm going to go ahead and do a solid line here. And I'm shading above that line, so it would be there. Now I want to look for the places where I shaded twice, and that would be anything in this region here. And now it says give one solution to each. Anything in this shaded region is a solution. So I'm just going to say, I don't know, 6, 0. It's just one example. There's lots of them, but 6, 0 is in that shaded region. Okay, 22. First one is a vertical line. X is less than or equal to negative 1. It is a solid vertical line that goes through negative 1. It's less than, so all the numbers to the left of, there you go. Second one's not in slope-intercept form. I'm going to get it there by subtracting 6x. So I have negative 8y is greater than or equal to negative 6x plus 0, or just negative 6x. Divide by negative 8. I got y is less than or equal to, and I flip the sign because I divided by a negative, and then a negative divided by a negative is a positive 3/4 x. So this is a solid line again. Y-intercept is 0. Slope is 3/4, so up 3, right 4. Down 3, left 4. And I'm going to draw my line. Okay, and I'm shading below that line. So that would be down here. The place where they overlap is down in this section here. A solution is anything in that shaded region, so I'm going to make sure I get there. So I'm going to say negative 4, negative 6. Okay, if you want to make sure that's a solution, you can take negative 4, plug it in for x in both of them, and negative 6 and plug it in for y. And if they make two true statements, it's a solution. Okay? And now, solving for x, this is a lot of Unit 1 right here. Various lessons, but a bunch of Unit 1. We'll go quickly because I think most of this is not too bad. I'm going to distribute the 2x, so 5x plus 2x minus 6 equals 3x. You know what? I'm going to combine 3x and 4x and make 7x minus 6. I'm going to combine 5x and 2x and say 7x minus 6 equals 7x minus 6. So I get negative 6 equals negative 6. The variables canceled on both sides. The remaining numbers are equal, so this one has infinitely many solutions. Okay. Number 24 is you want to solve for x. You want to get x by itself. There's other variables, but it doesn't really change how you do it. I'm going to get rid of the fraction by multiplying by n. So I have x plus g equals 7n. Then I'm just going to subtract g. So I have x equals 7n minus g. 25 is an absolute value equation, so you should get two answers here. First thing you need to do is get the absolute value by itself. So I'm going to add 7. What a lot of people will like to do is distribute the 2. Don't do that. You want to get rid of the 2 by dividing it. So x plus 4, absolute value of x plus 4 equals 5. So basically what I want is, I want this to be 5 or negative 5. So I can make two equations. X plus 4 equals 5, and x plus 4 equals negative 5. Subtract 4, I get x equals 1. But I also subtract 4, and I can get x equals negative 9. Either one of those solutions work, which is why they're a solution. Okay, next one. Cross multiply, I get 4 times 6x minus 3 equals 9 times 3x. Distribute the 4, I get 24x minus 12 equals 27x. I'm going to go ahead and move the 24x to the other side. I get negative 12 equals 3x. Divide by 3, I get x equals negative 4. 27, I'm distributing a negative 4. 6x minus 4x minus 20 equals x. 6x minus 4x is 2x minus 20 equals x. You might think you want to bring x over here to keep it positive, but actually you got to get it away from the 20, so I'm going to subtract 2x. So negative 20 equals negative 1x. Divide by negative 1, I get x equals 20. 28, I'm going to add a to both sides. So I get 8x equals b plus a, and then I'm going to divide everything by 8. So x equals b plus a divided by 8. Another proportion here. So I have 9 times 2x plus 3 equals 6 times 3x minus 2. Distribute, I'm going to get 18x plus 27 equals 18x minus 12. Look what happens to the variables on this one. They both cancel, and I'm left with 27 equals negative 12. Those are not equal. Therefore, this has no solutions. To get x by itself here, I'm going to clear the fraction. Multiply by 5. So I'm going to go 3xw equals 5y. Then I'm just going to divide by 3w, and I'm going to cancel the 3 and the w, and I'm going to get x equals 5y divided by 3w. Last one here is another absolute value. We'll subtract 8. That's negative 3. A lot of people will get there and say no solutions because it's equal to a negative, but that's why you got to clear everything first. So I'm going to divide by negative 3, and look what you get. The absolute value of 2x plus 1 equals 1. Now I can write my two equations. 2x plus 1 equals 1. 2x plus 1 equals negative 1. I'm going to subtract 1. I'm going to get 2x equals 0. Divide by 2, you get x equals 0. Subtract 1, I get 2x equals negative 2. Divide by 2, you get x equals negative 1. And that's the end of page